Okay, so in this podcast, we're going to learn about different types of nuclear reactions and how to draw them, how to write them. So there's three basic types of radioactive decay. There are other reactions too, but these are the three that we always learn first. Alpha radiation and beta and gamma radiation. So alpha radiation, or alpha decay, has the symbol, this little alpha symbol, which is a Greek symbol alpha, and it is made up of a helium atom with a 4 on the top, mass number of 4, and atomic number of 2, which is what makes it helium because it has an atomic number of 2. It's made up of 2 protons plus 2 neutrons. Because it has 2 protons, it's got a charge of plus 2, and because it has 2 plus 2, it has a charge of about 4 atomic mass units. It is very, very weak radiation. It can be blocked by paper. It's so weak, very short range, safe radiation. It's everywhere, and it doesn't really cause any damage. So here's how we write a reaction for alpha decay. So this is the alpha decay of uranium-238. So what we do is find uranium on the periodic table, and uranium is a U, and we're told that it's uranium-238, so the top number is going to be 238. Because it's uranium, the bottom number is going to be 92, because uranium has an atomic number of 92. So this is going to decay by alpha radiation. So we write the arrow, and then we write the alpha product, which is 4 and 2, He, and then we have to figure out what numbers are going to be left over here. So we've got 238, we took away 4, so we have 234 left. So the top number is going to be 4. We started out with 92 on the bottom, and we took away 2, so we have 90 on the bottom. And then because it's 90, we look up 90 on the periodic table, and we find out that that is thorium, which is Th, and so therefore the symbol is Th. So this is what is left over after we take out the alpha radiation. And that's how we write a nuclear reaction for alpha radiation. So here is the next type of radiation, and it is beta radiation, or beta decay. It has the symbol Greek B, which is beta. It is made up of an electron, which has a 0 on the top and a -1 on the bottom. So it's got a charge of -1, no mass, and it's a little bit stronger. It can be blocked by aluminum. So it's stronger than alpha, but not as strong as you can get. Its explanation is that a neutron breaks down and emits an electron and an antineutrino. So here's how we draw a reaction for beta decay of carbon-14. So it's carbon-14, so the top number is going to be 14, and C for carbon. Because it's carbon, the bottom number has to be 6. So it's going to decay and spit out this electron with a -1 on the bottom, and a 0 is on the top, so the top number is not going to change. It's still going to be 14. But the bottom number has a -1, so the -1 is on the same side as our final number, which has to be 7, because 7 minus 1 is 6. Okay, and then because the bottom number is 7, we look that up on the periodic table, and that is nitrogen, which is N. So the next type of radiation is gamma radiation, which is the highest energy. It has the symbol gamma, a Greek symbol gamma, very high energy nuclei, high energy radiation, no charge, no mass, and it has to be blocked by lead, which is why nuclear reactors in nuclear power plants are always lined in lead, and we do not write reactions for gamma radiation, so no reactions to write here. So other types of radiation include positron emission, which is where a proton is converted to a neutron and releases a positron, which is a positive electron, which is kind of a strange thing. It has no mass. And the particle looks like this. So it's an electron with a +1 on the bottom instead of a -1. And that gets spit out. So here we're going to write carbon-11 decay by positron emission. So we start with carbon-11, C, 11 on top, 6 on the bottom because it's carbon. And it is going to lose this positive electron with a 0 and a 1. The only thing we have to pay attention to are the numbers. The symbol here doesn't really matter. It is set by what the numbers are. So in order to make everything balanced, the top number is not going to change. It's still going to be 11 because of the 0. But the bottom number is going to be a 5 because 5 plus 1 was 6. So because it's a 5, it's going to be B for boron. And just so you know, in case you were wondering what happens to positrons after they are formed, they do not stick around. They don't last. They are annihilated, which means they disappear into energy. Another type of reaction is called electron capture, and this is where the nucleus absorbs an inner electron from the inside of the, one of the lower energy electrons. And the nucleus, the number of neutrons increases by 1, and the number of protons decreases by 1. So because the number of protons changes, the element does change. So here's the electron capture of rubidium-81. So find rubidium on the periodic table. It's Rb, 81 on the top, 37 on the bottom because it is rubidium. And it's going to add an electron on the left side of the arrow. So it's +0 and a -1. And because the top number didn't change, it's 0. So it's still an 81. But the bottom number is going to be 37 -1, which is 36. And then you find 36 on the periodic table, and it is krypton, Kr. So other types of things that can happen are one element smashing into each other or neutron bombardment. And these are just examples. We're not going to show reactions here, but just some examples of modern physics, high-level modern physics. These are the types of things that they're working on in the super collider and high-end research in physics. Here's an overview of the 3 types of radiation, alpha, beta, and gamma. And you can see that alpha radiation is stopped by paper, beta is stopped by aluminum, and it takes lead to stop gamma radiation, highest energy. So lowest, medium, highest energy. So what we're going to do here is on the worksheets in your packet, I want you to pause the video and go through and try to figure out the answers, and then play the video and check your answers and see how you're doing. If you have any trouble, go and see your teacher, and they'll help you. Okay, ready for the next page? Okay, next page. And then these last 3 reactions are overall reactions, not just fill in the blank. And they involve alpha decay. Remember, alpha is the helium atom. And then electron capture. And capture means it goes on the left side of the arrow. And then beta decay. And beta decay goes on the right side of the arrow.